Hi everybody. Because no one else has done so yet, as far as I can tell, I thought I'd try to write a sudoku solver in emacs lisp. Shouldn't be that tricky. I've already found a page with a lot of sudoku grids, so I'm going to pick one of these and try to solve it. Simple backtracking algorithm. Looks like there's a solution in common Lisp here as well, which may be worth looking at. So I have my emacs here. And I have my code here, so let's just copy this, the grid, and let's make a, oops, that's not right, what I want to do is this, sudoku, okay, go in here, let's just have a solver or code, yeah, okay, and that is the grid. So first thing to do is get the grid into a form which we can deal with. So let's turn this into a list of numbers. Set q local grid or board, whatever we want to do. And let's use some dash commands here. So we're going to require dash, and we're going to require not sure we're going to require F, we're going to require F, S, certainly. Okay, and let's do S join. No S lines. Okay, split it into lines to begin with. And then we're going to concatenate everything together into one long line. So if we just do this, we should see one long line. We do. And then let's do a string to list. And then we should see lots of numbers. And let's do a map partial. Let's just take away 0 from each number. Okay, good. So that gives us a list of numbers. Looks okay, I think. Yep, 00302 06. Run this one again, 0030206. So we've got the basic grid. Now let's talk about solving a sudoku using backtracking. It's going to be inside a CL label. We're going to call it, let's call it loop, the function. And loop's going to take a board, and it's going to take a current index, probably something else as well. Let's see what happens. And we're going to decide to do something based on the state of the board and the index, and either we're going to call loop again, or we're going to decide it's not worth it and we'll be finished. So there's one call which is the very happy step, which is equals index 81, which just means we've got to the end of the board. So it's no number 81, at which point we just return the board. This is the nice easy step. What is also a possibility? We have the problem that we're trying to, that the square is already filled. That's possible. So that would be a not equals 0 element of board at index. If it's not equal to 0, what we do is we move to the next index. So we do board, we call loop again with board at the next index. That's one further possibility. Okay, what's the next possibility? Is if it's not possible to fit something into the board, let's just call it not possible P, and we'll write it later. So we need the value of a guess. We need that as well. Let's have a guess here. So we're going to have to add the guess here as well. No, we don't. We start at 0. We start at 1 here. Okay. So if it's not possible, P, to put in the board at this index a value of the guess, then we just return nil. That's a dead end. No, we don't, do we? We try the next guess. Yes. Index 1 plus guess. So it's not possible to put a 2 there. We try to put a 3 there, for example, which means we need a way to get out in case the guess gets too high. So greater than 9, greater than guess 9, we return nil. That's a branch which just cannot continue. Okay, good. Got the index too large here. We have something's already set. We have not possible. So now we've got the case where it is possible to put something. So it's the last possible case, and there are two things to consider here. What we want to try to do is we want to try to place it and then see what happens. And if that doesn't work, we'll try with the next guess. We'll try to up guess by 1. So we'll try to put whatever the value of guess is at this index in the board and then carry on. And at some stage, if that works out, we're going to find ourselves in this branch and we'll return the board. And if not, we're going to try again, but try with the next number at that position. So we're going to add 1 to guess. So this is a loop of, and the command to do this is a replace at. Which way around is this? NX list. Okay, so index is the number, guess, board, that's the board. And then the index, we're going to move on to the next index. And we're going to start again with 1 for the guess. And there are 2 possibilities. That's one of the possibilities. That's where we place the guess and see if it works. And the other possibility is we loop again with the board, with index, but with 1 plus guess. So we try the next number. Okay, and this is basically the whole of the sudoku. And then at some stage we're going to call loop with a board which we're coding in from outside, with the index 0 and with the first guess of 1 for that index. So the only function which is left to right is not possible p. So let's look at not possible p and what that looks and how to write that. It's a function which takes a board and an index and a guess. And there are 3 branches, aren't there, in Sudoku? So it's an OR of contains P. We're going to have to get a line at line 4, index of board index. And if it contains the guess, then it's not possible to put it there. And the next thing we have to do is it contains P of call for index board index guess. And the last one is contains P square for index board index guess. And that one's going to be quite a tricky one to write, I think. Okay, that's the basic idea. We've got the not possible P, but let's do these. Some of these are going to be quite simple. The line for index is going to be very simple. So let's do that. Line for index. So we're going to get the line for the index 27, for example, which takes a board and an index. And what we do here is we just, let's see what's the easy way to do this. We split the board. So we take the board, we partition in groups of 9, and we take the What's the easy way to do this? Well, the easy way is to take the slice. We take the vex value, don't we? Okay, so we just take ELT, the element at. So what's the sequence? Okay. Let's do this differently then. Well, let's slice it then. Or we can just do it like this, can't we? Element at minus partition in groups of 9, the board, and the n that we want is the is going to be the division of the index by 9. Yeah, that makes sense. That means that can go away. So let's just think through this once. If index is 21, then index divided by 9 is going to be 2, and we want the second group. Yeah, that seems to be okay. Call for index, board index. Let's see how to do this one. What's the easy way? It's not going to be as easy like this, is it, unless we do a transformation of the board. Let's use slice. Then we can say we want every 9th element starting at a certain amount. So let's do this one. Let first index is going to be just that, which is, let's call that the x coordinate, so to speak. Let's call it x. And then what we return is just, yep, that's okay. What we return is just slice of the board, and from is x, and 2 is up to 81, and the step is 9. Yeah, that looks okay. Now we get to the tricky one, which is square for index. This is going to scare me a little bit, I think. Let's get the first x and the first y coordinates. Let's do it like that. So x we want first is, oh, hang on, I need the argument list. 9. I'm going to need a star here because this is going to build on each other. Divide by index 9. Then we have the first x. So the x is going to be something like 0, 1, 2, 3, 4, 5, 6, 7, 8. So the first x inside this square that we want is going to be 0, 4, 0, 1, 2, 0, 3, or 6. And the easy way to get that is just to multiply by 3, what we get by dividing x by 3. And the first thing, same thing for y. Okay, so now we've got our indexes. Then let's get the board and let's just partition it and then drop some stuff. So let's drop up to the first y. So we've now got the board divided into 9 horizontal lines of each of length 9, and we drop up to the first y, and then we take 3. And now we've got to do something clever. Now the S library, I always get this wrong. Let me do an example, see if I can get this right here. There's a CL map car of list, which you can do to a list of lists. Oh no, to a number of lists, isn't it? So if you have something like this, then it doesn't work because I forgot to quote it. Let's quote this. Then it takes, and it divides it up, as you can see down there, into, it reads it vertically as if these three lines were on top of each other. So we can use this here. What's the easy way to do this? I think we can just do a CL map car here, can't we? Almost, we have to apply it. Because what we're getting is a list of lists. We're getting this coming in without these. I think that's an apply, isn't it? Yes, that looks right. Okay. List, and we get the list of lists coming in, and then what we need to do is we just drop first x and we take 3, at which point we just need to flatten and we have our list. We have our elements which are in that list. I would like to see that running because I'm fairly unsure I got that right. Okay, then we need to build a whole function out of this, don't we? Define sudoku solve, which takes a board, and let's format this. This looks okay, as if it's indented correctly. Yep, and then let's just do a sudoku solve of, what did we call it? Did we call it starting board or something up here? Grid, we called it. Oh, let's not call it grid, let's call it start. Okay, we have start here. Okay, and rather than using loop board, what I would like to see is square for index of the board which comes in, and let's say the index is 1, and let's comment that out here, and let's have a message of this so that we can see it in the message buffer. Okay, good. Let's go back to 1 and eval buffer. Let's see what goes wrong. Oh, it didn't go wrong immediately. 090. Does that make sense? 90 000 301. It seems to be vertical, but who cares? Who cares if it's transposed? Of course it's transposed. We did this trip with CL map car. It's going to be transposed, but who cares? It doesn't matter. The order is not important. Let's see what happens if we use 80 here. Then we should see the last possibility, 503. Yep, there we can see it going down, 503, 000, 090. Okay, this looks good. Let's see if this works. Comment that out. It did something rather quickly. Is that a solution? I don't know. Let's add a function to print this. Define sudoku print. Let's call it that. Takes a board and How are we going to do this? Let's just divide it up into groups. No, just first of all, let's turn these things into strings. Number to string. Then we can divide it up into groups. And then let's concatenate it. Something like this will do it. Yep, that looks okay. Yep, we can use a partial function there as well. And then we just join the lines. So this looks like a way to solve it and a way to print it. And let's call that here on that. We get that coming out. Does that look plausible? Yeah, it looks plausible. I don't know if it's correct or not, but it looks plausible. We can try it out here and see what we can see if we see any problems. In the first line, we've got all possible numbers. Second line, we've got all possible numbers. Third line, yeah, this looks okay. It's not obviously wrong. The last line has got all numbers in it. So the last column, the first column has got all numbers in it. Yeah, this looks like to be a good solution. Okay, let me stop the recording. Many thanks for your time.